There we go, we're recording. Boys and girls, last. So this is an inclined plane, and concept zero with an inclined plane is that this is the angle that we want to use. So 0 means flat, 90 means a cliff. Yeah? Okay. If they are clever and or something and they give you like this angle, just find that angle and then proceed from there. Okay. And then concept 1, since that was concept 0, concept 1 is that we're going to make things that are up the plane positive, so displacements up the plane, accelerations, velocities up the plane will be positive, and ones down the plane we will make negative. Okay? And on a test, when you're solving, when you get to the end and you solve for an acceleration in the direction of the acceleration, if it's positive, it doesn't mean it's just in any direction. It means specifically that it's up the plane. And if it's negative, it's down the plane, right? So later on I'll ask you this on whiteboards, and it's very important that you know that it's not just positive as in it could be anyway. Positive means distinctly up the plane, right? And then finally we've got gravity, right? And gravity is going to act down the plane on this guy, right? Or gravity is going to act just straight down, right? In fact, that's kind of redundant, isn't it? Doesn't gravity define down? Yes? There's no down without gravity.
That's correct.
I think so. Okay. So this is, and I'm just going to write this here. This is the force of gravity down the plane. Now here's the trick. This object is not going to move up and down, right? This thing is going to move. I'm going to make that arrow a little bit shorter like this. Okay. This thing is not going to move straight up and straight down. It's actually going to move along the plane. So what we do to solve this is we take this force and we make it into components, one parallel to the plane and one perpendicular to the plane. Right? And this guy here, I call this guy the force parallel. Right? And it's not a force like as in strong nuclear force or gravity or something like that, electrostatic, Coulombic repulsion. Right? That force is just a part of Earth's gravity. It's the part that's down the plane, right? And then this part here, I call the force perpendicular. Okay? And that's what holds you against the plane. Now, I used to prove, because I loved geometry, right? I used to prove that these angles are congruent. Yeah? They look kind of like they're the same, don't they? That's kind of a good proof, isn't it? Not very good. Right? They're either, by the way, it's either this angle or this angle that's equal to this one. It has to be, doesn't it? In your heart of hearts, you know that, right? Did you guys, I love geometry. My geometry teacher was this guy named Mr. Capacious. I don't know his first name, right? And it was capacious not as in like he holds a lot. It was capacious as in Greek, a Greek name. You could imagine, yeah. And he would, at the end of a lesson, he would like teach this lesson, right? And then he would sit back, honest to God, he'd sit down in his desk, lean his chair back, open his little book that he had these things written in apparently, right? And he would say, without hesitation and without fault, every day, he would say, with that in mind, turn to page and do problems. Yes? Are you picturing this? So as a class, one day, we all talked before class. And when he leaned back in the desk and opened the book, we all said out loud, with that in mind, turn to page, and it was just all in unison. It was amazing. It was a wonderful thing, right? And he turns and looked at us, and then he went back to his book and laughed and told us our assignment. How do we get there? Oh, because of geometry, and because I love geometry. Mr. Capacious, if you're watching, that was for you. Okay. Anyway, it turns out that story is more fun than proving that, but you can prove it. You have to use like angles complementary to the same angle are also congruent or something like that. Okay. But anyway, you can sort of tell if this angle, if that went down to 0, right? Wouldn't this angle also get smaller and smaller? The angle between straight down and straight into the plane would be smaller, right? So that means that this side here is actually opposite the angle, isn't it?
Yeah.
Yes? Okay, so the parallel force there is going to be the side opposite, which is sine. So it's going to be mg, hypotenuse, right, is mg sine theta, right? And then this guy is going to equal mg cos theta, whatever that angle is, right? Now this is not in the data packet. So how do you remember it? I could never remember this. Let me give you a clue. Here's how I would remember it. You could just remember it by drawing this vector diagram and figuring it out again, right? Or you can do this, right? Here's the force along the plane. If the angle is 0, it's level, isn't it? How much of the force of gravity is making that block move along the plane right now? Nothing, correct? I think in the other class somebody said all of it, right? It's like, we're in The Exorcist, right? It's like, no. Assuming we're not in the movie The Exorcist, right? There's no force making that move along the plane, right? Okay, so definitely there's no parallel force right now. And the sign of 0 is what? Well, I could never remember that either, right? But my calculator always remembered it, right? It's either 0 or 1, right? Which one is it? If you don't know, take your calculator and go sine of 0. Which one is it? It's not 1.
0.
It's 0.
Sillies.
Try to take your calculator. Sine of 0 is 0. Yeah, cosine of 0 is 1. There we go, right? So, right now, what it's saying, what our formulas are saying is that there's no force along the surface. All of the force is perpendicular to the surface, yes? This thing is not, by the way, this is a level surface. Things don't roll on level surfaces. They just stay there. Okay, this is why we make our floors level. Okay, because nobody wants a floor where the marble rolls that way. By the way, when I looked at houses, when I was buying them, I would take a marble and place it on the floor. And I was like, oh, if the marble rolls toward the living, like the fireplace in the living room, that's normal. Because fireplaces are heavy and they inevitably will settle a little bit. But if if you put a marble in every room of the house and they all roll east, not such a good sign. You know? Not such a good sign, right? Okay. Now think about this, right? As it gets steeper and steeper, well, the extreme case is that it's a cliff. How much of gravity now is parallel to the plane? Every single bit of it. Sine of 90 is 1, unless you are in radians, right? And then it's like some random number, right? Okay, so yeah, there it is, right? Now it's all the force is parallel to the plane. How much is into the plane? Gravity is not holding this against the plane at all. It's just there because of happenstance, right? Okay. Now if I tilt it like this, what do we have more of? Perpendicular or parallel? More parallel, right? Not very much perpendicular. In fact, you're not being held against the plane very much at all, are you? Yeah. Okay. Now, has anybody skied on anything quite this steep?
No.
Maybe sometimes. Would you ever ski on something this steep on Mount Hood where the snow is like packed ice? This would be, you'd have to be really good to ski on this on ice, right? Okay. Yeah. How about powder though? Yeah, in fact, in powder, you have to ski on really steep stuff, don't you?
Yeah.
Because if it's like this, you don't go anywhere, do you? You just sink in, right? So you've got to be skiing on really, really steep stuff. And this is part of the reason why powder is fun, is that I'm not being held against the surface very much, am I? Right? And so I'm just going boom, boom. It's easy when you do the up unweighting, right? You're actually flying off the surface. You take air. Isn't that fun? That's why it's fun. Yes, I went backcountry skiing in the Wallowas, and we found this avalanche chute on the north side, right? That was just perfect, right? We made the guide go down first. Here, you try this first, right? You know, that was good, right? And then we just practiced. We walked up to the top and skied down, walked up, skied down, right? And it was. I mean, if it hadn't been powder, there's no way I would have done it. But it was so slow because it was powder, right? That it was just fun. I mean, it's just like it's the only powdery sort of stuff I've skied on. Right. Now, the other interesting thing about degrees of slope is that 30 degrees, if you have a true 30-degree slope on a hill, right now that doesn't look so steep. If this were a ski slope, it would be a cliff. 30 degrees. Anybody know that about ski slopes? Okay. So you know, the bunny hill is like 5 degrees or something like that. So skiers always overestimate something that looks like a cliff, and you're like, that's 90 degrees or 80 degrees or something. It's like 30. Okay. You know, probably the top of Heather Canyon is like this, right? Looks like